Hi guys, it's Mr. Ellman, and we're going to take a look at how to take an idea for an object and draw it on paper in a way that everyone who looks at it should understand exactly what it's supposed to look like. This is one of the methods that engineers use. I'm going to start by taking a piece of graph paper, and it can be plain paper, but I'm going to use graph paper. It's a little easier to work with. And I'm going to divide it into 4 sections that are pretty even. Okay, I'm going to label the sections. This is going to be my top, my front, and my side view. In this box, I'm going to draw a 3D drawing of what it is that I want to create. This is a little difficult. You don't have to do this part, but you may have drawn yours out somewhere, or you can just try to draw what yours might look like in 3 dimensions. So let's say for this simple object, I'm just going to create a box. And like that. Okay, that's a 3-dimensional view. And I'm also going to put, let's say, some shapes on each side. I'm going to put a rectangle on this side. I'm going to put a triangle on this side, and maybe a circle on the top, just to identify the sides. Okay, so here's where I'm going to draw just the top view if I were looking directly at it. Okay, so for the top view, I am going to say that it is this long. So it's 1, 2, 3, 10, 11, 12 boxes by, let's do the same here, 5 boxes. 3, 4, 5. So it's also going to be 5 here, and it's also going to be 12 here. Okay, so that's the top view, and then there's a circle. Okay, the front view is only going to be this side, and it has to line up exactly with where the top edge of that side is right here. Okay, so that's the top edge. So it's going to be here, and it's going to be 4 squares tall. 1, 2, 3, 4, like that. And 5 over. 2, 3, 4, 5. Four, 5, 4, 5. And we have a rectangle on the front. Okay, so then the side view is this view right here, the one with the triangle on it, and I know that has to line up with this. So that will start, let's say, right here. Okay, and how do I know how long that's going to be? Well, I've already made that side up here. It's 12 squares long. Good, because it's going to be the same length here. This edge is going to be the same length as this edge. Okay, this edge here is this line and this line. 1, 2, and 11, 12. Okay, and then I know this is going to be 4 squares tall. So it's going to line up with that edge. And this has, the side has what shape on it? It has a triangle on it. So there's my triangle. Okay, and so I know this is 12 and 12, and this is 4, and this is 4. So we're looking at the side view here. This is this shape right here. 12 long by 4 tall. This edge is this edge and this edge, which brings me to the front, which is 5 wide. This edge right here in the top is the same as this edge, 5 wide, and then back to here, which is 12 long or deep. Okay, so that is my multi-view drawing. This whole thing is my multi-view drawing I can also give you the technical term. The engineering term for this type of drawing is called orthographic projection. Okay, let's say I wanted to create something a little more complicated. We're going to make another multi-view drawing. So I'm going to make my sections. Okay, and what I'm going to create this time is a basketball game. And first I'm going to do my 3D drawing. And again, this is a little more complicated. You don't have to do the 3D part, as long as you know in your mind what you want it to look like. Okay, so that's what I want to end up with. So again, I'm going to do my top, front, and side. Okay, so for my top, it's like I'm looking down on this side. Six, 16 by 6. And of course, this will also be 16, and this will also be 6. And my top view also should show the hoop that I'm going to make out of cardboard. But I'm not going to see anything else because the sides are standing straight up. Okay, so now the front view is just going to be looking at it this way. And it does have to line up with this, with the top view. I'm going to make that 8 tall. And it's going to be 6 wide. Okay, that's just the bottom part here. 6 wide by 8 tall. So now I am also going to see the top part here with the basketball hoop. So that's going to come up a little further. And let's say that comes up another 6. 5, 6. Okay, and then I also know that this is angled a little bit. This part is a little higher than this part here. Okay, so I'm going to make another, let's say it's angled just a little bit, like right there. And I'm going to see the basketball hoops from straight on. So I'm really only going to see it like that. Okay, and it should match up. Okay, so this is the front view of this side, and I know I made it a little differently than my drawing, but it's actually going to be a little taller. This should be the exact scale drawing of it. So that's 8. So this line here, that's going to be 8. This line here, though, is going to be 14. Okay, so altogether, that's going to be 14. This is 8 right to here. And that's 6. And this is 6. Okay, so now the side view is going to be looking at it from this side. Okay, so I know that it's going to be 8 tall. I hope I have enough room. I'm going to start all the way over here. Okay, so it's going to start there, right there. I know it's going to be 16 deep. This is going to be 16. So 1, 2, 14, 15, 16. And I know it's going to be 14 tall. 1, 2, 3, 12, 13, 14. So that's how tall the back is going to be. The front is going to be 8. So I know there's going to be a line to connect those. That's this line right here. Okay, but this part right here, where the ball is going to land and roll down, it's a little lower than the sides. So I do need to indicate where it is, because I won't be able to see it looking from this side, but because there's another line there, because it's behind there, I'm going to draw it with a dotted line, indicating that it's hiding behind this plane. So it is going to end up right here, and it's going to connect to this corner right here. So it's going to be like that. Whoops. Okay, but I just said it's going to be a dotted line. Okay, and then I'm also going to indicate that there's a basketball hoop right here. And that's also going to be a dotted line, because I can't see it looking from this side. So it's like that. I'm going to fill in my dimensions, which are 16 from there to there, 14 tall. This side is 8. And this is actually 10 right here. And I can use trigonometry to figure out this side, but I don't have to do that because I'm just going to draw my lines on the cardboard. Okay, so now how do I transfer these dimensions to my real object? Okay, well, maybe I want this to be 8 inches tall, but maybe I don't. Maybe I want it to be 12 inches tall. Maybe I want it to be 20 inches tall. I'm going to have to do a little bit of multiplication. So here's going to be my scale. Each square is going to be equal to 2 inches. That's my scale. Okay, so that I know that 8 squares on here is going to actually be equal to 16 inches. 16 inches on here is actually going to be equal to 32 inches. 14 squares here is actually going to be equal to 28 inches, etc. And it doesn't have to be that a square is equal to 2 inches. I can make it equal to 4 inches or 5 inches or 6.5 inches if I wanted to. Okay, now let's build this game.